everyone, I'm very glad to share with you this course about GaussDB, instance installation. To know GaussDB, let's start from its installation. Database installation and deployment is a complex process. It involves comprehensive planning in the early stage, such as network plane division, disk planning, hardware selection, database deployment mode, port matrix, database version, operating system, and file system parameters, as well as how to determine and configure the GUC, parameter baseline of the database. How do we help users quickly deploy GaussDB databases? We use tools to take over some standardized and repeatable operations. Users only need to make database plans. To help with GaussDB planning, we provide the deployment white paper, which describes the constraints on GaussDB capabilities in lightweight scenarios. We also provide the LLD template to help users plan the database. After the planning is complete, users can use the management platform to deploy GaussDB, and the platform provides one-click database installation and deployment. Upon completion of this course, you will learn how to use the management platform to install GaussDB instances, and how to handle some common problems. This course consists of 4 parts. In the first part, we will learn about GaussDB management platform. In the second part, we will learn how to use this platform to install GaussDB instances. In the third part, we will have a look at how the installation is performed. Last, we will introduce how to locate causes if the installation fails. Let's take a look at GaussDB management platform. The management platform is an out-of-the-box, stable, reliable, scalable, and easy-to-manage database service that does not depend on any cloud foundation or underlying cloud services in the Huawei Cloud Stack scenario. The lightweight GaussDB database has a comprehensive performance monitoring system, user permissions management system, and multiple security measures. It provides a professional database management platform, which allows users to easily set up, operate, and scale out databases, simplifying routine O&M, so that users can focus on application development. GaussDB management platform consists of 3 layers: standard agent layer, basic and intelligent O&M layer, and open ecosystem layer. The standard agent layer, deployed on GaussDB instances, collects metrics of DB instances, and performs O&M operations. It occupies few resources, because it is isolated by group, and does not compete for database process resources. It provides comprehensive multi-layer security, refined isolation design, and precise management of process overhead, minimizing performance loss. The upper layer is the service layer, which provides basic and intelligent O&M capabilities. Basic O&M capabilities cover instance O&M, DR management, platform O&M, and log security. Instance O&M provides GaussDB instance lifecycle management, such as instance provisioning, parameter modification, and backup and restoration management. DR management provides GaussDB streaming DR, intra-city DR, geo-redundant DR, and DR drills and switchovers. Platform O&M includes task center, agent management, and global system parameter management. Log security includes collection and display of GaussDB database logs, log analysis, and log downloads. AI for DB. Intelligent O&M is an autonomous O&M system with improved performance optimization, circle tuning, and exception diagnosis based on AI for DB capabilities. It covers self-monitoring, self-diagnosis, self-tuning, self-recovery, and self-protection functions, such as circle diagnosis and tuning in seconds, intelligent inspection, E2E monitoring display of the full link execution of circle statements on CNS, on DNS, such as the execution duration, internal database invoking, and key weight events, index recommendations, and circle throttling. It can be deployed in just a few clicks, and helps O&M personnel resolve O&M pain points. Unified domain-based modeling, unified deployment framework, and full idempotence. For task scheduling, ensure highly reliable delivery of O&M tasks. The top layer is the open ecosystem layer, which provides a user-friendly web interface and various O&M apps for interconnection with third-party platforms, making a unified management console for the public cloud, partner cloud, HCS Online, IES, Huawei Cloud Stack, and lightweight GaussDB. This page is the instance details page, including basic instance information, performance monitoring, diagnosis and optimization, log analysis, backup and restoration, parameter management, connection management, audit logs, and tags. The figure shows the real-time monitoring data of an instance, system resources such as CPU, memory, disk, and network, and database performance metrics, such as service load, locks, and process resources can be collected and displayed. The second part is about how to install an instance on GaussDB management platform. Instance installation consists of 3 steps. The first step is bringing a host online. This means you need to record the information about the node, also called host, where the instance is to be installed to the management platform. Then, the system automatically checks and configures the environment of the node and displays the items that do not meet the requirements. After all node information is recorded, install the instance. During this process, the management platform installs and deploys GaussDB. After the installation is successful, you can connect to the GaussDB instance and perform post-installation checks. First, let's look at how to bring a host online, which covers standard configuration and inspection of the environment to be installed. Go to the Data Centers page, select a data center, and click Add Host. When the host is added, the base agent component is installed on the host. For subsequent standardization check and upgrade operations, the figure shows the page for adding a host. You need to specify all required parameters. Host alias. The host alias cannot exceed 64 characters. Type. Currently, only physical machines are supported. Other host types will be added in the future. OS. Select Kylin or UOS. CPU vendor. Select Compang, Intel, or Hygon. Enter the management IP address, service IP address, and data IP address. If any 2 of the IP addresses share the same plane, enter the same IP address for the 2 IP addresses. For example, if the service and data services share the same plane, enter the same IP address for service IP address and data IP address. If only one IP address is used, enter the same IP address for the 3 IP addresses. Specify an SSH port. The value ranges from 0 to 65535, but cannot be 8002 or 12017, which are for internal use only. Last, enter the password of user root and provide a brief description. After filling in the information, click OK to perform a standardization check on the host. Note that the information selected and entered on this page must be the same as the actual information about the host to be added. Otherwise, an error occurs. After the parameters are specified, the management platform performs a standardization check on the host environment. The check results are displayed in a list, including the check item name, check item description, check result, current value, and recommended value. The check results include passed, failed, and warning. If mandatory items do not meet the requirements, the check fails. If recommended items do not meet the requirements, a warning is displayed, but subsequent operations are not affected. The list on the right displays the check items, which can be divided into 3 parts. The first 4 items are about hardware information, such as CPU, memory, CPU to memory, and disk. The middle items are about software environment information, such as the operating system version, firewall, time synchronization, and installation of dependent software. The last part is about operating system parameters and file system parameters. Currently, 17 check item categories and 50 check item subcategories are supported. In the future, check items will be continuously enriched to ensure the standardization of online hosts. Let's have a look at some key check items in detail. These are hardware check items. The network must be 10G or 25G Ethernet. Two NICs must be bonded for redundancy. The memory must be at least 64 GB. In the production environment, the memory must be higher. It is recommended that at least one 8-core 2.0 GHz CPU be used for function debugging. In commercial deployment, it is recommended that one 16-core 2.0 GHz CPU be used. The CPU settings must be the same on each node. Disks include system disks and data disks. Configure RAID 1 for system disks and RAID 10 for data disks. The disks must be big enough. In terms of software, the operating system is checked. Currently, x86 or ARM-based Kylin version 10SP1 and version 10SP2, as well as x86-based UOS version 20 are supported. In the future, ARM-based UOS will be supported, and many more other operating systems. The file system must be ext4. In terms of operating system parameters, netgit for TCP, max TW, buckets indicates the maximum number of TCP, IP, connections concurrently. Remaining in the time-wait state, the recommended value is 10,000. Netgit for TCP, TW, reuse indicates whether the sockets, in the time-wait state, can be reused for new TCP connections. There are also kernel semaphore and system memory parameters. These operating system parameters are critical to a running database and will be automatically configured and checked by the management platform. In terms of file system parameters, the soft and hard limits for file handles and the stack size of the thread pool must be large enough to ensure that the GaussDB instance runs normally. After the check is passed, the host comes online. You can check the host status in the data center. A host can be either initialized or in use. If being initialized, the host is online but is not used yet. There is no DB instance deployed or managed on the host yet. If being in use, the host has a GaussDB instance running on it. The figure shows the host management page, which displays the number of hosts in the data center. For each host, you can edit and modify host information, delete the host, and view check reports. After the host is brought online, go to the instance installation page. On this page, specify a series of parameters of the instance to be installed. The parameters are as follows. DB instance name. Enter a meaningful name containing 4 to 64 characters. DB engine version. Select a version for the instance to be installed. Operating system. Kylin and UOS are supported. Architecture. x86 and ARM are supported. CPU vendor. Kunpeng, Intel, and Hygon are supported. Host type. Currently, only physical machines are supported. DB instance type. Select primary, standby, or distributed. Deployment model. The deployment models include 3-node distributed, 9-node distributed, 2-node primary standby, 3-node primary standby, and 5-node primary standby. In this page, the left part is the screenshot for setting parameters during instance installation, and the right part is the description of the parameters. Transaction consistency needs to be set only when you select distributed for DB instance type. The options include strong consistency and eventual consistency. AZ. An AZ is an area where power and network resources are isolated from other areas. Management address indicates the list of hosts that can be selected after the host comes online successfully. Database port indicates the port provided by a database for external systems. This means that the port can be connected to JDBC. The default value is 8000. The value ranges from 1024 to 39,998. Some internal ports cannot be used. This slide shows how to enter the database configuration information. Administrator, the default value is root, and cannot be changed. The root account has the highest permissions available to users, such as create role, create DB, and monitor admin permissions. Administrator password. The password must be strong enough. Common weak passwords are also verified to prevent the passwords from being easily obtained by attackers. Confirm password. Enter the administrator password again. Parameter template. The parameter template is associated with the baseline values of the GUC parameters of the database. After the parameter template is selected, the parameters are automatically configured during instance installation. This slide is about confirming the instance information. If all the information is correct, you can click Submit to complete the request for creating an instance. Instance installation is time-consuming and is an asynchronous task. After submitting an instance creation task, you can view the progress of the task in the Task Center of GaussDB Management Platform. If the task status is displayed as completed, the instance is successfully created. You can click Task Details on the right to view the task execution details, for example, the number of subtasks and the number of tasks under each subtask. You can also check which step is being executed. After the DB instance is created, you can view and manage it on the Instances page. You can view information about each instance, including the name, ID, DB, instance type, status, database port, storage type, and operation. You can click an instance name to go to the Instance Details page for further management. To change an instance name, click the Edit icon next to the instance name. To copy an instance ID, click the Copy icon. Having an instance ID is especially useful when you use APIs. Almost all APIs require instance IDs to specify the instances to be operated. That's all for installing and deploying GaussDB instances using the management platform. The next slide describes the instance installation principles. We can further explore which GaussDB interfaces are called during instance installation and the steps for installing an instance. GaussDB is installed and deployed using the adapter interface. The first step is to upgrade the agent of GaussDB management platform. This means that you need to deploy the agent of the latest version on an instance node. The second step is to install agent and to perform instance preinstallation and installation. The adapter interface is a standard CLI interface provided by GaussDB. The interface is kept compatible with earlier versions. GaussDB management platform integrates the adapter interface to perform O&M operations on GaussDB. O&M agent is a key kernel component. It provides O&M command interfaces in HTTP mode for the adapter interface to call. Therefore, executing an O&M command involves GaussDB management platform, the adapter interface, O&M agent, and kernel processes. The O&M agent installation is simple. You can run the O&M agent installation script as the database user Ruby. After the installation is successful, run the ps-ux command to check whether the O&M agent.py process is running. If the process is running, the installation is successful. If the process is not running, you can view the installation logs to locate the fault. The purpose of preinstallation is to configure the instance environment to ensure the instance can be installed normally. After the preinstallation is complete, you can install the instance. The commands for preinstallation and installation are similar. You should note that the values for the func name parameter in the two commands are different. As you can see in the command example, echo is followed by some key value pairs enclosed by single quotation marks in format. And then a pipe operator is used to direct to the executable file O&M controller of the adapter interface. If the value of ret code is 0 in the command output, The installation is successful. After the installation, run the cmctl query cvdip command if the value of cluster state is displayed as normal and primary normal is contained in the command output. The instance is successfully installed. The last part describes how to locate the root cause of an installation failure. Let's use a specific case as an example. If an instance fails to be installed, you can see an instance creation failure in the instance list. In this case, you need to copy the DB instance ID and then search for the DB instance that failed to be created. Based on the DB instance ID in the Task Center, you can click Task Details in the Operation column. In the Task Center, you can locate the failed task. The failed task is displayed in red. Click Operation and select View Failure Details. The detailed failure cause is displayed. In most cases, you can find the root cause in this step. In this example, the failure cause is displayed as Install OM agent failed. You can log into the backend system to check the logs about the failure. Before your login, save the full name of the init OM agent task executed on the node for later log search. When viewing logs in the backend system, you can view the async result point.dat file first. This file records the execution status of all asynchronous tasks. You can search for the failed task in the file, for example, init OM agent. If you have checked information about error message in the log and no valid information is found, let's continue to locate the fault. You can view the agent log of the agent component and search for the full name of the init OM agent task in the log to view the task execution status. As you can see here, OM agent fails to be installed. Here are some common log files. The async job result. Dat file records the execution status of all asynchronous tasks. The agent log file records the run logs of the agent component. The OM agent or agent log file records the run logs of the kernel OM agent. In the Gauss log directory, run logs of kernel components, such as CM, CN, DN, GTM, and OM, are stored. You can view these logs to locate problems of kernel components. On the previous page, the OM agent run log shows that the root cause is that the CA certificate failed to be created due to insufficient permissions. The following figures show the process of locating an instance installation failure. You can view the cause of the installation failure in the workflow of GaussDB management platform and record the ID of the failed task. You can also log into the failed node in the background and check the execution status of the failed task in the async job result.dat file. Then, you can view the run log file agent log of the agent component and search for execution details by the ID of the failed task. Still, you can check the kernel run logs. If kernel components caused the fault, you can check the kernel run logs. Okay, that's all for this course. Let's make a review. You can install an instance using GaussDB management platform with a few clicks. First, the management platform is an out-of-the-box, stable, reliable, scalable, and easy-to-manage ONDM tool that does not depend on the Huawei Cloud Foundation. It has a standard agent layer, basic and intelligent ONDM layer, and an open ecosystem layer. Second, installing a GaussDB instance involves bringing a host online, installing the instance, and performing a check after installation. The most important part is bringing a host online, because it allows you to check the hardware and software environment of a host and standardize the configuration. After a host comes online, you can install an instance based on the standard configuration environment to reduce errors. Third, the instance installation depends on the adapter interface, a standard CLI interface provided by GaussDB. This interface can be integrated by the management platform. The installation process includes installing and deploying the agent component, installing OM agent, pre-installation, and installation. Last but not least, if GaussDB instance installation fails, you can view failure details of the failed task on the management platform. If necessary, you can view related logs to locate the fault. That's all for the course. Thank you for watching.